All right, pre-calc, we are doing the phase shift today, and this will be the last part of graphing the sine function. So 446, we're going to do the phase shift, and then 447, we'll put everything together in, basically what can possibly happen to all of the different steps in the function. So for our bell ringers today, what we're going to do is just get a little practice with adding these. Now, this is something you can do on your calculator, just like we did before with the conversions and degrees to radians and stuff like that. You can do this on your calculator. We just leave pi out of it. Okay, so this is the same thing on your calculator as doing 2 pi plus 1/2. My board's disconnecting. So anyway, this is 2 pi plus pi over 2 is the same thing on your calculator as doing 2 plus 1/2, and then just put pi back in your answer, okay? So 2 plus 1/2, we don't want to write this as 2.5, okay? So when we write this, we're going to write this as 5 over 2, but again, like I said, we're going to bring the pi back into it. So 5 pi over 2, that's the same thing as 2.5. 3 pi over 2 plus 4 pi, again, on your calculator, you can enter 3 over 2 plus 4. When you do that, again, change it back to an improper fraction. You should get 11 over 2. So we want to bring pi back into it. So 11 pi over 2. Pi over 2 minus pi over 4. Same thing as 1/2 minus 1/4. So 1/2 minus 1/4 will give you 1/4. So pi over 4. All right, now that concept right there is basically what we're doing when we're doing the phase shift. All right, so here we go. And again, this is the horizontal change. It just has a fancy name for the trig functions. It's called the phase shift. So in our equation up here, so you can see all of the different parts that we'll go over in the 447 notes. We'll go over all 4 of these parts. But what we're going to focus on today is this variable c, which is our phase shift. This will move left and right exactly the way that we did things like in the functions x minus 2 quantity squared, right? So this minus 2, it's the opposite of what we would think, and this would actually move it to the right too. Okay, if it's a plus, it moves it to the left. If it's a minus, it moves it to the right. And again, we talked about the reason why for that earlier in the year, so I'm not going to go over that today. We're just going to go over this process, all right? So let's just jump into this first example here, sine theta minus pi. So sine theta minus pi, and what we're going to do is start off with our parent function. So we have, there we go, we got 1, we got -1. Make this a little bit longer here. We got first point pi over 2, next pi, next up 3 pi over 2, and the last one is 2 pi. Our graph, again, we've seen this a lot over the last 5 days of notes. The graph of sine theta or sine x, it's going to have this general look to it for our parent function. And again, if you have no idea what I'm doing right here, that is probably because you need to get caught up on some video notes, all right? So go back, catch up, rewatch all of those, and you'll see what we're doing here. All right, so what we are going to do, again, we're going to take this and we're going to do the opposite. So this is minus pi, which means it's going to go to the right pi units. So we're going to take each of these points and we're going to do the opposite. We're going to add pi to it. All right, so what I'm going to do is I'm going to make my list. All right, I'm going to make my list of my 5 points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now we're going to do the same thing every time. And again, like I said, it's the opposite of what you see here. So we see a minus pi. That means we're going to do the opposite. We're going to add pi. So we're going to add pi to all of these values. So what I do when I'm doing these functions is I do not put the y-axis in. I just draw my x-axis for now. And what I do, so I don't forget anything, I have 5 points. So I'm going to go 1, 2, 3, 4, 5. And then I'll put the y-axis in later. All right, so I am not going to go put the y-axis in to begin with. I'm going to do that later on after I get all of my points, okay? So let's go through this here. So 0 plus pi, that's a pretty simple one. We end up with pi. So my first point here is pi. So you can see what happened is this point right here that was at 0, 0 now got moved over to pi 0. All right, next one, pi over 2 plus pi. And again, if at any point during this video you need to pause this, then do it. Pause the video, try it on your calculator, and make sure you get the right answer. Okay, so pi over 2 plus pi is going to give you 3 pi over 2. So that's my next point, 3 pi over 2. Next up, we have pi plus pi. Treat pi like a variable. So this is like x plus x would give us 2x. So that's like 2 pi. All right, so next up is 2 pi. Next up, 3 pi over 2 plus pi. And again, this is the same thing in your calculator. If you do 3 over 2 plus 1, this is like a 1 pi. So 3 over 2 plus 1. All right, so when you do that, you should end up with 5 pi over 2. All right, so that's our next point up here. Oops. 5 pi over 2. And the last one, 2 pi plus pi, that gives us 3 pi. 3 pi. Which, speaking of which, I totally missed Pi Day because I was out on quarantine and totally missed Pi Day on Monday. March 14th is officially Pi Day for all the math nerds out there. So I completely missed that, but oh well, next year I guess. So anyway, back to the problem. So those are the new points. Now what I'm going to do is once I fill in all of my x points, I can see these are all positive. So that means my y-axis would be right here. All right, now the y-axis isn't changing at all. It will change in the 447 notes, but for today, this is where it will be. It's just the 1 to -1, so that's the way it is. Now, what we're going to do is we're going to track this. So each of these points, 0 was moved to pi. Pi over 2 was moved to 3 pi over 2. Pi was moved to 2 pi, and so on and so on. So when I come up here to my blue graph, I'm going to say, all right, the point at 0 got moved to pi. So this point here got moved to pi. It's going to have the same general look. So I know it's going to go up, back down, and then back up. So I know it's going to have that same look. But just remember, each of these points gets tracked to a new point. So pi over 2 gets tracked to 3 pi over 2. So this point that was at pi over 2 was at 1. That is now at 3 pi over 2, 1. Next up, we had the point pi. Well, that got tracked to 2 pi. So pi 0 gets moved to 2 pi 0. 3 pi over 2, let me scroll down here. 3 pi over 2 got moved to 5 pi over 2. So this point, 3 pi over 2 was -1. That means 5 pi over 2 is -1. And remember, we have to end where we began, so we know that this is going to be at 0. But again, that was because 2 pi was tracked to 3 pi. 2 pi was at 0, so that means 3 pi is 0. So we go up, connect your dots, back down, back up. There's your new graph. So what we're doing here, you can see what's happening. The graph is just being basically sliding over to the right pi units. And again, just like when we did the other ones, the minus means it's going to move it to the right. A plus means move it to the left. And you'll see that here in our next example. So this red graph is your final answer. Again, make sure you have your the 3 things I'm looking for. Well, 4 things really, but the first thing you need your function. The second thing you need to have your y coordinates. The third thing you need your x coordinates. And then the fourth thing is actually your graph itself. So all four of those things, you need to have all of those in your homework in order to get credit for this. So make sure you have all of them. All right, next one here, we're going to, again, start with our parent function. So we're going to start out with sine x. All right, we're going 1 to -1. First up is 0. Next is pi over 2. Then we got pi. Then we got 3 pi over 2. And the last one that we're using is 2 pi. And again, the graph doesn't end there. That's just where we're cutting it off. You got to cut it off somewhere. You can't graph it forever. So that's just where we're stopping it. So f of x equals sine x. Here's our parent function. Again, one more time for these notes. And here we go. There we go. All right, so let's make our list. All right, we're going to make our list of all of these x points. So we're starting at 0. Then we have pi over 2, pi, 3 pi over 2, and 2 pi. Hopefully that all fits on the screen there. I'll slide it up a little bit just in case. All right, so we have a plus pi over 2. So remember, it's opposite. So plus pi over 2 means I'm subtracting pi over 2 from all of these points. All right, now, just like in the last example, what I'm going to start with is just an x-axis. All right, that was horrible. Let's try that again. That's a little better. All right, start out with an x-axis, and I'm going to put 1, 2, 3, 4, 5 lines. All right, there's 5 points. 0, pi over 2, pi, 3 pi over 2, 2 pi. There's 5 points, so I put 5 lines. I'll fill the y-axis in later. All right, sometimes one of these points will give you 0, and then you know, all right, that's where my y-axis is. The y-axis is where it's 0. Okay, the x value is 0. So if one of these gives us 0, which in this case it will, that's where the y-axis will be. All right, so let's start. First up, 0 minus pi over 2 gives us negative pi over 2. And I also want to point out, let me back up a step here. We're starting this over 0 to 2 pi. That just talks about your parent function, okay? 0 to 2 pi is just referring to the parent function. When it gets moved around from the period and the phase shift, we're no longer 0 to 2 pi. That's just referring to the parent function, okay? So you can see that again here in this graph. We're going, now our first point is at negative pi over 2. Okay, and again, we're going to repeat this process all the way down. So pi over 2 minus pi over 2. Well, what does that give you? Pi over 2 minus pi over 2 is 0. So I know this next point here is at 0. Well, what happens at 0? You guessed it, that's the y-axis. So let's fill that in. All right, this is going to be 1 down to negative 1. All right, let's keep going with our points here. Again, feel free to pause and rewind and do whatever you need to make sure you understand this. Pi minus pi over 2. Again, on your calculator, you can do 1 minus 1/2. 1 minus 1/2 gives you 1/2, so that's pi over 2. All right, so there's my next point, pi over 2. That should be a pi. That kind of looks like an H. All right, up next, pi. Computer's freezing. Oh, it didn't scroll down all the way. There we go. 3 pi over 2. Let me put some scribbles here so it won't get rid of the bottom part. 3 pi over 2 minus pi over 2. Pi over 2. There we go. 3 pi over 2 minus pi over 2. Well, this is just going to give us pi. All right, 3 pi over 2 minus 1 pi over 2 would give you 2 pi over 2, which 2 pi over 2 is just pi. So my next point is at pi. And the last one, 2 pi minus pi over 2. And again, in your calculator, you do 2 minus 1/2. 2 minus 1/2. It'll give you 1.5 or 1.5, whatever. We want to change that to a fraction, improper fraction. So 3 pi over 2. That's our last point, 3 pi over 2. All right. So let's put this on the graph here. Again, we're going to graph on our coordinate plane with our new values, tracking all of these x coordinates over to their new points. So 0 got shifted over to negative pi over 2, right? 0 got shifted over to negative pi over 2. So that means my point at 0, 0 is now at negative pi over 2, 0. Next up, pi over 2 was moved to 0. So pi over 2, 1 gets moved to 0, 1. I missed my point there, but next up, pi. Well, pi got shifted over to pi over 2, so that's at 0, right? Pi 0 got moved over to pi over 2, 0. 3 pi over 2 got moved over to pi, so we're at pi negative 1. And last up, we got to end where we began, but 2 pi got moved over to 3 pi over 2, so we're right there. So there is our new graph. And again, we want to make sure that we put our function. So f of x equals sine of x plus pi over 2. And again, another thing I would suggest is plug these things into Desmos. Check your work, check your graphs with what they look like on Desmos. Just remember to cut it off where you need to. Your graphing calculator will do it, but that doesn't look as nice, and you can't really see things very clearly. So Desmos is a better option. You guys all have Chromebooks, so I would suggest using Desmos. That's my recommendation. So again, if you have any questions on any of this stuff, send me an email and let me know. Otherwise, practice your homework problems. And like I said, 447 notes, we're going to put everything together into one type of example. So practice those problems and let me know if you have any questions.